Good afternoon. Thank you all for being here today. You know, I remember this time last year at re:Invent 2017 when we launched and unveiled AWS Fargate to the world. What an exciting time it was. And I can tell you that I'm equally excited to be back here this year, 1 year later. 1 year of now having operated the service in production, 1 year of building the next set of features on this platform for you, 1 year of scaling the service out from 1 region at launch last year to 11 regions today. And most importantly, 1 year of having all of you, our customers, use this service for your real-world applications and give us invaluable feedback that we use every day at our jobs. So thank you very much. Please keep it coming. Over the course of this 1 year, through all this experience that we've gained, we're learning so much about the way we need to think about our applications that are running on Fargate. And some patterns are now starting to emerge. And today, I want to talk to you about one such pattern that has really stood out over the past year. And I won't tell you what the pattern is just yet. We'll keep that in suspense and build up to it through the course of the presentation. But I will tell you that this particular pattern, this particular idea, has been central. It has been core to every single feature that we have designed and built for you on Fargate. And my hope today is that at the end of this talk, I want to sow that seed of that idea, of that pattern in your minds so you can take that idea back to your applications that you may be thinking about migrating to Fargate. But before I go any further, I want to introduce you to Joseph Bulger, who is a principal architect at Turner, and he's going to be co-presenting this session with me today. Turner is one of our larger Fargate customers, and we're really happy to have you here. Thank you, Joseph, for spending the time here. And so after I give you a little bit of the AWS perspective of how you should be thinking about your applications on Fargate, Joseph will talk to you about a customer-side perspective of their migration story onto Fargate. So without much further ado, let's get started. When I first started to think about what message I wanted to deliver here on this platform today to all of you, I started to put my slide deck together. And the very first slide that I put together was my bio slide, fairly common thing to do. I thought I'd tell you a little bit about myself. My name is Archana Shrikanta, and I am a senior software developer and the engineering lead for AWS Fargate. And then I thought I'd tell you a little bit about my journey with AWS. I've been with AWS for about 7 years. I started out on the EC2 team, and then I transitioned to the Elastic Container Services team. And about 2 years ago, I moved to seed and become the founding engineer on the Fargate team. Now, as soon as I put this slide together, something interesting struck me. Call me lucky, but my career progression through Amazon basically exactly maps on to the evolution of compute platforms on AWS. And I thought this was a perfect starting point for today's conversation here. AWS started out with EC2, which is plain old virtual machines in the cloud, what we know as EC2 instances. And then we started noticing that customers were starting to adopt containers and were starting to organize their applications within these EC2 instances as containers. So we launched the Elastic Container Service, or ECS. And ECS allowed you to scale and manage containers within clusters of EC2 instances at scale. Now, some of you who've used ECS may recognize this model as what we call the EC2 launch type of ECS, as opposed to the Fargate launch type. And it's called the EC2 launch type because these containers are running on EC2 instances within your account. But then customers told us that they really only cared about the applications that were running within the containers. Managing and maintaining this EC2 instance or the VM layer around these containers is just undifferentiated heavy lifting that adds zero value to your business. And so we listened, and we launched Fargate, which basically removes the need for you to manage any kind of instance or VM or server underneath your containers, and you can just launch your containerized applications as first-class citizens in the AWS cloud. Now, the thing to note about each of these transitions here is that even though it may look like this is just an infrastructure level change, something that your IT department deals with, it really isn't. It's not just an infrastructure shift. It's fundamentally changing the way in which we're thinking about and building and designing our applications. And this couldn't have been more evident than it was in that very first shift from VMs to containers. In fact, let's take a few moments here and quickly recap the kind of shift that containers brought about. The infrastructure change with containers was that we went from running applications just as loose processes within virtual machines to running each application in its own little resource and namespace isolated sandbox that we call a container. The design paradigm shift that this brought upon us was that it forced us to think of these applications as completely decoupled, independent entities, even though they may be running within the same virtual machine. And this idea of decoupled applications really led to a whole burst of innovation in the application development space. We found a need to decouple the packaging and builds of applications, and the container image format and the Docker build process really enabled that for us. There was a need to decouple deployments for these applications. We were no longer just deploying these bulky VM images with everything in it. In fact, we were deploying individual container images within these VMs. And so there were a lot more deployments, and there was a lot that happened on the CI/CD front to enable faster and safer container deployments. There was a need to decouple the scaling of these applications. Again, we're not scaling at the VM level, we're scaling at the individual container level. And so there was a lot of investment over the past 4 or 5 years in the cluster management and orchestration space with solutions like ECS and Kubernetes and EKS. Decoupled locality of applications. Applications no longer assumed that other applications that they wanted to talk to were running locally within the same virtual machine, or even that they were running on well-known addresses of remote machines, because the whole placement of containers on VMs became such a dynamic decision. And so we needed a way for applications to dynamically discover where other applications lived. And service discovery and all the wonderful solutions we have there was the answer to that. Basically, all these buzzwords that we know as the microservices era, I think all of us can agree that microservices really fundamentally changed the way in which we think about our applications. And so the question ahead of us now is, how is Fargate shifting the paradigm? The infrastructure shift here with Fargate is that you're going from running containers that are hosted on EC2 instances that are running in your account to running containers that are just magically hosted in the cloud for you. And the underlying server underneath your containers is completely abstracted away from you, which means you don't have access to log into it. You don't have the ability to perform any kind of customizations on the server. You basically lose all interaction touch points with the underlying server. And the design paradigm shift that I think this needs for us to operate successfully in this kind of a serverless world is that not only do we need to decouple applications from one another, but we also need to decouple applications from the underlying host. And this is the idea that I was saying has been very central to everything that we've done on the Fargate platform for you. But in order to truly realize this vision of decoupling the application from the underlying host, I think it's a joint responsibility between you, the customer, and us, the service team behind Fargate. And I can tell you from our side, again, for every single feature that we build, the engineering team behind Fargate evaluates it against this design principle. Is this particular implementation of this feature sufficiently decoupling the application from the underlying host? And if the answer to that is no, we go back to the drawing board and come up with a new way to achieve the same goal. And the commitment that we need from you, the customers, is to really embrace and adopt these newer modes of operation that are coming up on the Fargate platform. And instead of just blindly asking you to change the way you're doing things, I wanted to walk through a few practical examples of features where we examined the state of the art, decided it wasn't a good fit for Fargate, and then came up with a new way to do it. Oftentimes, you'll find that if you're operating containers on servers that you own, whether it's EC2 instances or virtual machines in your own data centers, you're used to doing things in a certain way. And sometimes those old methods of operation don't quite translate to the Fargate world. And so today I wanted to give you a little bit of insight into why some of these things might work differently in the Fargate world. So we're going to use these three examples. I'm going to talk about how we decoupled your application's networking from the underlying host. I'll talk about how we decoupled the permissions model for your application from the underlying host, and finally, how we decoupled monitoring for your application. So let's start with the first one, decoupled networking via the AWS VPC networking mode. Now, before we had AWS VPC networking mode, there were two modes of operation, networking modes of operation, in the EC2 launch type of ECS, bridge and host networking mode. We took a good look at these, and we decided that this was not a good fit for Fargate. Let's see why that was the case. Starting with bridge networking mode. So in bridge networking mode, you have an EC2 instance, and if you're running any standard flavor of Linux, every machine gets a default network namespace, what we call the host network namespace. And the physical network interface that is used for all incoming and outgoing traffic in and out of this EC2 instance, what's also called the F0 interface, lives within this default network namespace. And if you're using this instance to launch Docker containers, presumably you've installed Docker on this machine, and one of the networking components that Docker sets up for you is a Docker 0 bridge. Bridge is really just a way to connect namespaces together. So you can have a process that's running in one network namespace talk to another process that's running in another network namespace through this bridge. And now when you launch a Docker container, what Docker does is it creates a separate isolated network namespace for this container and launches the container process within it. But any traffic, incoming or outgoing, to this container from outside of the EC2 instance must still transit through that physical F0 interface that's attached to your host, because that's the only way to talk in and out of the EC2 instance. I'm also going to introduce the concept of a task here. A task is a logical group of containers. And if you've already used ECS or Fargate, you might be familiar with this concept. But it's a logical group of containers that still represents a single application. For example, you may have an Nginx container that's fronting your backend web server. And you'd put both those containers into a single task. And the guarantee is that both those containers will land within the same VM. And oftentimes, there is a need for two containers within the same task to talk to one another. And in this case, in the bridge networking mode, Docker has no idea of tasks. Tasks is a higher level ECS API construct. To Docker, these are just two containers. So when you launch that second container, Docker puts that second container within its own namespace, a separate namespace. And now if these two containers need to talk to each other, because they're in separate namespaces, they need to transit through the Docker 0 bridge. And now we looked at this picture and said, OK, how do we take this model to the Fargate world? And we noticed that there were a few problems here. Problem number one, any traffic in and out of your task needs to transit through this host-level network interface. What do you do when the host interface isn't yours? It's AWS's host interface. Problem number 2, any communication between containers within the same task is transiting through this Docker Zero bridge, which is also something that's pre-installed on the host that's outside of the sort of sandbox of the task. And so if we remove all the host-level components from this picture, you can see that there are a lot of loose ends here. How do you, as the customer, actually communicate with your task? And how do containers within your task talk to each other? So that wasn't going to work. Let's quickly examine the host networking mode. What happens in the host networking mode is instead of launching your containers in their own isolated namespaces, Docker will launch all your containers into the host's default network namespace itself. And in some ways, this is almost a grosser violation of that idea of we need to decouple from the host. But it has some merits. Both the containers within the task are now in the same networking namespace, so they can talk to each other, and that's solved. But communications in and out of your task, outside of the instance, still needs to go through this physical @ 0 interface of your host. So that wasn't going to quite work either. And so we said we needed to come up with a new way of doing this. And so we came up with the AWS VPC networking mode. What we did with the AWS VPC networking mode is when you launch a task, we create a task-level network namespace and put all the containers within this task into that task network namespace. And so now, when your containers want to talk to each other within the task, they're both in the same namespace. They just use local hosts to talk to each other. But we still have to solve the problem of external communication. And for that, what we do is we create an elastic network interface, or an ENI, within your VPC, within your network, and then we attach that ENI as a secondary network interface to this host. And this secondary network interface, it doesn't live in the host namespace. It lives within the task's network namespace. And so now any communication in and out of your task can transit through this task network interface without relying on the host @ 0 interface. And so now we can remove all the host components from this picture, and we actually get a fully functional, working, standalone Fargate task. And so to summarize what happened here, we innovated and built a new way, a task-native way for you to be able to do networking at the task level, such that each task gets its own ENI, each task gets its own IP address, each task gets its own security group firewall rules, without any reliance on your host's networking stack and rules that govern the host @ 0 interface. And that was a good fit for the Fargate paradigm. And if any of this container networking stuff piqued your interest, there is a 400-level deep dive into container networking that's happening tomorrow. I highly recommend going to this talk if you're interested in more details on the AWS VPC networking front. Moving on to the second example. Decoupling permissions via the task role. Before we had task role, you would launch an EC2 instance, and typically you launch an instance with an instance role, an EC2 instance role, an IAM role. And then when you launch a task within this EC2 instance, let's say that this task wants to access some other AWS resource, like a DynamoDB table in this case. You need credentials to be able to access this DynamoDB table. You need an access key and a secret key. And by default, the way this works is the AWS SDK or CLI that you're using within your task to make that DynamoDB API call is wired by default to load the credentials associated with your EC2 instance role. And that means that the IAM policy that you attach to your EC2 instance role needs to have this DDB permissions associated with it. Now, if you launch a second task onto this instance that's accessing some other kind of resource, let's say an S3 bucket in this case, the SDK within that task is also falling back to use the same EC2 instance role. And so the policy that goes with your instance role also needs to allow S3 actions. Now, there are a few problems with this model if you try to move it to the Fargate world. Problem number one, you're relying on your host's role in order to give your tasks permissions to do the things that they need to do. And that's not good for Fargate. Problem number two, because all the tasks on your instance are sharing that same role, you're now opening the door to this kind of cross communication. Your task one that only really needs to access the DynamoDB table can now also access this S3 bucket that it has no business accessing just because it's sharing the same role that a neighboring task might also be using. And we certainly don't want this kind of thing in Fargate. We need to isolate the tasks. And so if you remove the host components from this picture, it doesn't work for Fargate. Where do these tasks get their permissions from if the underlying server and the role associated with the server is not your role? And so we came up with this concept of a task role. And it's really a very simple idea, and it's exactly what you think it is. When you now launch a task, you can create an IAM role with just the permissions needed for that task and pass it along in the launch task API call. And we worked with the AWS SDK team to change the wiring to have it now load the credentials associated with that task role that you passed to us during the task launch. And so if you launch a second task, you can create a second role and pass a second role onto your second task. And this was perfect because it removed the reliance of your tasks on that EC2 instance level role. And so we can remove all the instance components from this picture, and we get standalone tasks that work in the Fargate world. So again, we innovated a task-native way to do permissions such that you can specify fine-grained permissions for that specific task without having any reliance on the permissions model of the underlying host. And that was a good fit for the Fargate paradigm. And finally, my last example for today is how we decoupled monitoring via the task metadata endpoint. And for this example, I'm going to use the specific use case of Datadog's integration with us. For those of you who don't know what Datadog is an AWS partner company, and they are building solutions to enable you to basically collect metrics and logs from your applications that are running on AWS and view it in a nice UI on their website. So before we had the task metadata endpoint, this is what the Datadog integration story was. You have the default network namespace there that we talked about earlier. The Docker daemon itself runs within this default network namespace of the host. With Datadog, you have to also install the Datadog agent itself as a daemon, and the Datadog daemon also runs within this host network namespace. And now when you launch your application container, presumably if you're using the AWS VPC networking mode, the container and the application lives in the task network namespace. And what happens here is Datadog queries Docker for stats about your container, like CPU utilization, memory utilization, disk, and network bandwidth. It queries all of these Docker stats against the Docker daemon, and then publishes it out to their Datadog service, so you can go view those statistics on a web page. And we looked at this and said, this is a great feature. You know, EC2 mode tasks have this feature. Why shouldn't Fargate tasks have this feature? We want to enable this feature for Fargate. But we couldn't take this solution as is to the Fargate world. And the reason for that, problem number one, the Docker daemon, the Datadog daemon itself is running in the host network namespace. Problem number two, the Datadog daemon is getting its information, the stats that it needs, from the Docker daemon, which is also running outside of the task sandbox in the host network namespace. Problem number 3, because the Datadog daemon is running in the host network namespace, it's using that host network interface, the Eth0 network interface, to publish metrics out to the Datadog service. And so if we remove the host components from this picture, how is all of this going to work anymore? And so we went back and sat down with Datadog and came up with a different way of doing things in the Fargate world. The first change that we made was, instead of installing the Datadog daemon, the Datadog agent as a daemon on your server, Datadog came up with a containerized version of their agent. And what you can do now is, when you launch your task, instead of just launching your application container, you can also pull in this Datadog agent as a sidecar container. And now the Datadog daemon is actually running within your task network namespace itself. The second change that we brought about, the Datadog daemon still needs to query something and get the stats. And we don't want it to be reaching down into the host network namespace to talk to Docker. But we said, this is a reasonable use case to say, I want to know information about my application containers in my task namespace. I should have access to this information. And so we built a task metadata endpoint. It's a local endpoint that's available within your task network namespace that surfaces various metadata about your task, like the task ID, the IP address of your task, including Docker stats, CPU memory stats, etc. And so now the sidecar container, the Datadog container, can just hit this local endpoint within the task namespace to get application level stats. And also, because it's running within the task network namespace, it can use the task network interface to publish metrics out to the Datadog service. And so now, if we remove the host level components here, you get a cohesive picture for the Fargate world. And really, again, to reinforce the point here, with task metadata, we innovated on a way to give you a task-native way to query information about your containers without necessarily giving you access to information about other tasks, right? And more interestingly, what Datadog did here, they worked with us to move from a model that required you to pre-install a daemon on the server to a model where you can just an application can just pull in all the supporting containers it needs into the task sandbox itself. And I think that was a great example of how they were evolving to meet this new paradigm requirements. And if you are interested in this particular topic of how to gain visibility into your applications that are running in this serverless mode, there is a breakout session tomorrow that dives deeper into this topic. And with that, I don't want to take too much more of your time, and I want to let you hear about Turner. So my takeaway to you is really examine your applications that you want to bring to Fargate to see if you have any touch points, any assumptions that you're making about the underlying host. And if you are, investigate if there's a different way of doing it. Is there a different mode of operation that we've enabled in Fargate that lets you do the same thing? We probably have. I like to think of it as a jigsaw puzzle where we own the bottom piece and you own the top piece. And the more precise we can get about that line of interface between those two pieces, the faster you can iterate on your piece, and the faster we can iterate on our piece, so that we can give you a better platform underneath your tasks. And if you really feel like, I've looked at everything and there really isn't any other way to do this, I must have access to that underlying host, please come and talk to us. We want to build a solution for you. And we're innovating every day back at home in the team to find new ways to allow you to safely decouple your applications from the underlying host, because that is the future of serverless computing. Thank you very much. And now I'll hand it over to Joseph.
Thank you, Archana. Hey, everybody. I'm Joseph Bolger, the principal architect at Turner. And today, I'm here to tell you about our journey to Fargate. But before I get started, let me tell you a little about us. For those of you that are not familiar with Turner, some of our brands include TBS, TNT, CNN, Cartoon Network, Adult Swim, just to name a few. We currently have the 9th largest collection of web properties in the world. So why did we at Turner choose to adopt Fargate as a technology? Well, to get us started, let me give you a brief history of our path up until now. A while ago, we realized the benefits of containerization. And we knew that in order to meet the demands of our business, we were going to need to containerize. So we did. We started to learn how to build Docker containers, and we started to leverage the benefits of them. And through that process, we began to understand the other need of orchestration. So we went about building a platform that we called Harbor, which is basically an internal PaaS running on top of a Kubernetes cluster. And we began migrating teams onto this platform. And it worked really great for them for a long time. But around the same time that we were getting peak adoption on Harbor, Turner needed to start instituting a culture shift, or to Archana's point, institute a paradigm shift of a DevOps culture in our teams too. A lot of our teams adopted that mindset very quickly and immediately jumped into other technologies, including ECS. And it provided many benefits for them, and still do today. But then Fargate came out. And for the rest of the teams that were still on Harbor, we saw Fargate as a gateway technology to get them into this new DevOps world. So why Fargate? What did Fargate do that really engaged and allowed them to get into this DevOps mindset? To help answer that, let me give you a little bit of context. You see, these teams that were still in Harbor, operationally, most of what they had to do was done for them. They didn't have to create load balancers or allocate target groups or make Route 53 records. They didn't have to do any of that stuff because it was all done for them by Harbor or by the Harbor team. And so because of that, they kind of lived in this world where they focused most on their container levels. Fargate was a technology that enabled them to get into the DevOps culture and mindset without having to take as big of a leap as they would have had to take in other technologies. The leap that other technologies required of them was too large. There's too many things for them to learn. For example, with Fargate, as Archana was pointing out earlier, all of your host level concerns are abstracted away. You don't have to manage the host level. That allowed their teams, our teams, to only focus at the container level, which is what they were already used to doing. And so because of this, our cloud architecture team began building tooling around the Fargate product to accelerate the adoption and the move into this new DevOps world. The result ended up with reduced costs, both in terms of compute, because Fargate allowed most of these teams to actually save on compute costs, but also in time, because it took them much less time to actually get up and running. One key aspect of that tooling was to build a scaffolding CLI that would allow the teams to accelerate into deploying their compute clusters. This was key because it gave our teams a full stack of something that they would use in the Fargate compute cluster without needing to know exactly what it did. It provided a full stack of Fargate compute cluster, compute that was easily deployable with minimal understanding required. It also provided them a great starting point to learn. So not only did it build the stack for them, but also provided them the code that they would need to go back later on when they actually had time to learn about each individual thing that was being allocated. It also provided a huge cost savings because these teams didn't have to build an entire stack. They were able to leapfrog into their infrastructure without having to know each and every individual piece. So what does this scaffolding look like? It starts off by creating a Terraform TFRs file, and you have to provide a few key properties, like you have to tell it what region you're going to be in, what VPC do you want to deploy to, what profile, what are the subnets, stuff like that. And then the Fargate create CLI will take that TFRs file and generate for them an entire stack. The result is you get an entire AWS stack necessary to run, for example, a web server. You get a fully working compute cluster in Fargate, along with all the ancillary technologies in AWS that you need to run your server, or your web server. This is where our teams began to see huge benefits. They were only a couple of Terraform applies away from having a fully running Fargate cluster on their account. Once the cluster was up, then they needed to start managing and operating it. So we began leveraging the Fargate CLI to do that. They needed to do things like get information about it, like what kind of tasks were running on the service, or what was the endpoint for the load balancer, things like that. They also needed to scale it, both horizontally and vertically, to try to right-size it. They also needed a way to deploy it in their CI/CD process. Once the teams had their clusters up and running, the next step for them was to migrate their CI/CD process. And that was basically a few key changes that they had to make. The first of which was they needed to log into Docker with their new AWS ECR. Once they were logged in, they then needed to take their Docker image and push it into that ECR. And once they had that image pushed into the ECR, they then needed to deploy that image into their Fargate service. This is what the Fargate journey looked like at Turner. And the results, we've had a lot of success. We've migrated over 500 services. Of those 500 services, we've had around 700 tasks in them. That's come about by over 300 migrations. across 100 AWS accounts, and we've done all of that in less than 12 months. Cartoon Network runs on Fargate. Adult Swim also runs on Fargate, just to give you a couple examples. And I've also prepared a little demo for you guys here today to show you some of the tooling that we've been talking about that accelerated these teams into this DevOps culture. I want to show you the Fargate Create scaffolding tool and show you how our teams generated stacks and just how smooth it can be to get a compute cluster up and running. And if we have time, I'd also like to show you the Fargate CLI that our teams use to get information about their clusters and what a lot of them use to deploy with their CI/CD process. So what I have here is the beginning of a Terraform TFVars file. And I've predefined for us, to kind of save us some time, an example web server that I want to spin up. So I've already put in all the properties that I'm going to need to run this. These are mostly things that your teams would need to go into the AWS console and look up for the most part, or a lot of this, like your project name or your product name and things like that. But once you have this running, or once you have this defined, you run the Fargate create command. And it's going to ask you a few questions. Today, we're going to take the defaults just to make it quicker. But here, you can see it's asking you things like, do you want HTTPS support? It'll make a certificate in the certificate manager, for example. Do you want auto-scaling? Do you want an IAM role for your CI/CD process, stuff like that? We're just going to take all the defaults, but basically what it does is if you don't want something, it's just going to remove a Terraform file so you don't have it. And the end result, after you've done that, is it will build an entire Terraform set of scripts that you need in order to get your Fargate compute cluster up and running. The first thing it does is it creates a base folder. In the base folder, it's going to do two things. It's going to define a S3 bucket that we're going to use to store the Terraform state. And anybody that's familiar with Terraform state knows when you have multiple people on a team trying to actually allocate infrastructure with Terraform, you want to have a common place to store it because you don't want to have different Terraform states sitting on different computers. So that's the purpose of that. And then the second thing that it's going to do is it's going to allocate for this project a ECR for the application that we're going to build. So right now I'm just going to have it do a Terraform apply real quick and have it build it. This one doesn't take long. The next one takes a little bit of time, so I'm going to get this one running real quick so I can talk while it's going. So the second thing that we're going to get into is the environment of the application that we're going to build right now. So real quick, I'm going to get this running. And then we'll talk about what's going on in here. Okay, so what do we have here? Well, the way that this template is written out, each and every file that you're seeing here is an individual infrastructure function that you need in order to get your Fargate compute cluster running a web server. That's what we're building today. So there are things in here like you see the auto-scale Terraform files to do either time-based auto-scaling or performance-based auto-scaling. They also have meaningful defaults in there, so your teams don't have to define a bunch of values just to get things working. So for example, if you look at the auto-scaling performance file, you'll notice like the low threshold is at 20% and the high is at 80. The time one's similar. For any non-production environment, it'll shut down the cluster. It'll throttle down the task to 0 after 7 o'clock at night, for example, and you can change that. The compute cluster itself is actually allocated inside the ECS Terraform file. And you also have things like the load balancer, you have the listeners, and you also have the roles that the tasks are going to be given for your permissions. The bottom line here is it creates the entire stack for you. So literally, in about 5 or 10 minutes, our teams, once they know what their the VPCs are going to put it in, or their subnets are going to put it in, and some of the tagging that we use, they have a full stack of compute running in AWS, ready for them to push to. So we're still waiting for the load balancer, which is typical. So let me jump over here. I want to show you something. So I went ahead and I made one yesterday, and I have a backup. So this is actually the result, what you're seeing here, of the Fargate service info command on a cluster that I made earlier. So you can see things like what Docker image is running on how many tasks. Is there one being allocated or provisioned? You can see things like your environment, some of your environment variables. You can see what the load balancer endpoint is, stuff like that. In fact, if I go over here, I can show you guys. No, I can't. It should probably shut off. Oh, so we're actually done here. So let me show you. So I'm going to run Fargate service info. And then, boom, this is our cluster running. It comes pre-deployed with a default backend. So it's not actually the application that your team would be running, but it's the starting point to get them there, right? So now is when you would begin the migration of your CI/CD process to actually push your app's Docker image into your service. All of the things that I just showed you are open sourced and available on GitHub. Please feel free to take this stuff for a spin and let us know what you think about them. The Fargate Create repo or CLI is the tool that I just showed you that scaffolded an entire stack for that compute cluster. And the case that we ran was actually a web server, but it can do other types of infrastructure too. In fact, the Terraform ECS Fargate repo is the scripts that the Fargate Create CLI uses to scaffold out all the Terraform files for you. And then lastly, the Fargate CLI is the thing at the end that we used to get information about the cluster. And with that, I will give it back to Archana. Thanks, everybody.
Thank you, Joseph, for that. That's basically all we had for you today. Please do fill out the survey in your mobile app and tell us how you felt about this talk. And both Joseph and I will be outside in the hallway, so if you have any questions, feel free to come hit us up. And thank you all very much for your time and patience here.